Hey everybody, Harold here. Today I thought I'd show you how I handled the Maven Halloween challenge. Um, it's out here on Maven Analytics. If you haven't done these before, I've done several in the past. You could check out my videos in the hospital and rewards, challenges, train times, etc. This challenge's objective was to take a data-driven approach, become the most popular trick-or-treating house on the block. Find three treats you'll give out to guarantee that all trick-or-treaters find something they love. The data set is a CSV with 85 records, 13 fields. If you've been following my channel, I do these in Power BI usually, but I've also started doing a lot of R, and this data set in particular lent itself to statistical analysis in R. So I'm going to do some cleaning, transforming in R, and then take it to Power BI. So let's go to RStudio. So here we are in RStudio. We need to load some packages. If you don't have them installed, run the install.packages with the package name in double quotes inside parentheses. If you've done that already, go ahead and load them. You can say library or require, and then just the name of the package, no quotes in the parentheses. So we need Tidyverse, VizDat, and Broom. I'll show you why we need those later. Then we need to take the candy CSV, put it in your working directory or include the whole path. Make sure to escape your doubles, your slashes with another slash, and read a CSV from the reader package in the Tidyverse. We're going to call our object candy, data frame name candy. Then, if you read my notes, in case I screw up, I always make a backup. So candy backup is candy. And a great place to look at your data frames in R, a great way to get a first look at your data frames in R is Glimpse. And you'll see, let me drag this up a little. We have 85 rows, 13 columns, just like it said in the description. One character and a bunch of doubles. Editor name, and which is the candy bar name or candy name. We could get a dime or a quarter. Uh, and all these attributes, which are doubles, taste, type of candy, sugar, price, winning percentage. So there's our data frame at a glance. Another thing I like to do real quick is to run a VizDat on it. It's a great package for visualizing your data for missingness and types. So you say VizDat candy, and we get a nice, I'll blow it up for you and drag it over. This nice plot here, observations on the Y and column names on the X. Character is salmon, numeric is blue. There are no missing values or they would show up. So this looks great. Nice clean data set you dive into. Close that. I also like to use VizDat for VizCore. It runs a quick visual analysis of the correlation between the numeric variables. To do that, you need to select only the numeric variable column. So say candy and pipe, select where is numeric, pipe that in and run the VizCore then. And what you get here is, let me blow this up, zoom, a beautiful table showing visually the correlation between your variables. Of course, win percent with win percent is going to be 1. So dark brown is 1. Total correlate, everything's correlates 1 to itself, of course. Dark blue is a negative correlation. So chocolate fruity. People don't like chocolate and fruity, or pluribus bar, or so that's a negative correlation. The blue, no correlation at all, is the lighters, and the darker browns are good correlation. Like chocolate here, there's a lot of darker brown, the middle brown in the chocolate column, so that may have a statistical significance. So we'll follow up on that when we do our analysis. That's a BizCore, and that's a great way to look at correlations visually. Now, another thing I want to do is add a total attributes for each variable, or each candy bar column. Like how many of these do they have? Are they chocolate and fruity and caramel? So on and so forth. So what I need to do is add up the ones and zeros for each candy type. So here, I'm going to make a real quick a new data frame called candy tastes good, which is candy, and pipe in row wise. So that tells R to add across instead of down. Then we're going to add a column using mutate called total attributes, which equals the sum of across and these variables by these variables. Then I need to ungroup all that so I can perform further operations and arrange in descending order by total attributes and select the candy name, competitor name, and total attributes. So let me create that object and let's view it. So we have competitor name, candy name, Baby Ruth, 5 of these attributes. I may cut some of them out when I go further, but for right now, Baby Ruth, Snickers, and Snickers Crisper have 5, and Milky Way, etc. have 4, and so on down. So we might want to concentrate on giving out these. They have all these great things about them. We'll have to look further, but that's a good direction for us. So let me go back to my candy script. Now that I've checked that out and it looks good, I'm going to go ahead and add that to my candy data frame. This next statement. So now it's a part of candy. So I've got a total attributes column in my candy data frame. Next thing I want to do is uh, we picked out chocolate in our initial analysis as a possible highly correlated variable. So let's run a linear model on that. Chocolate as the independent variable and win percentage as the dependent variable. So LM model chalk, linear model win percentage, chocolate, and the data is candy. That doesn't show you anything. You have to run the summary or something to view the statistics. So here we've got a statistical summary of the relationship between win percentage and chocolate. Intercept here is the predicted winning percent for candy that's not contained chocolate. So 58% would be the opposite of that. So that's good. 18.779, the estimate, shows that candies that have chocolate are expected to have a win percent that's 18.779, points higher than those without. Uh, the p-value is extremely low, indicating a high significance. It indicates the null hypothesis is not true. There's a high significance, very low p-value, indicating strong statistical significance. The multiple R squared down here, 45.2, saying about 40.5% of the variation in win percentage is explained by whether or not the candy contains chocolate. That's huge. Even if you count the other variables, the adjusted R squared is still almost 40%, 39.8 here, 39.8. And again, the p-value is really low, so this looks like a good predictor. We might want to just give out chocolate. And if you check your candy bowl weeks later, I think what's left in there is not chocolate. It's usually the other fruity and hard candies. So, okay, maybe we just want to give out chocolate. We'll keep looking. Uh, so now I want to fit a linear model to all the variables. So choose predictor variables. Y'all can copy this off of my GitHub repository. I'll put it all in there. To fit a linear model. So I choose my variables, then I fit a linear model that maps them across all variables as they relate to win percentage, and then add a column for variable and returns the summary stats. The model summaries is going to map the data frame of predictor variables and the fit linear model and get summary I created up here. I'm going to do candy with stats equals candy. And I'm going to loop through the variables. Filter for the stat for the current variable. Add the stats as new columns right here. And if nothing was found, put no statistics found for variable. So let's check that out. So every uh, variable now has a p-value, a statistic, an estimate, and a standard error. What I'm going to do now is I'm going to go back to Candy. I'm going to write those model results. I created model results up there to a data frame into a. I'm going to write the model results data frame I created earlier to a CSV file called model results.csv. I've already done that, so I won't run that. And then also write the updated Candy data frame to a CSV. And now we should be ready to go to Power BI. So here we are in Power BI. And here's my visuals. So I'll go through them one by one. Here's the candy name and the total of their taste attributes. I put it to 4 attributes and just thought I'd show this nice table here. You can make a graph with it or something if you want to. The next would be I just took the candies and ranked them by win percentage. And to do that, I added a column in DAC, ranked by win percent. And if you've seen my video on rank X, you'll be familiar with it. If not, and you're having troubles with it or getting a bunch of ones, maybe go watch my video. But rank X, a 1-column table of the values in the candy column, and then win percent, rank by win percent, descending, dense. So I'm ranking across all rows in the candy table by win percent, descending order, dense. So that's my ranking table. I thought that was a nice little visual. Here is where I've put the model results. So you can see the estimate, statistic, standard error, and p-value for each variable. Chocolate up here at the top. Price, which I don't think really should be considered because they're giving away the candy for free. So you should probably discount anything based on price. The hard and fruity pluribus, negative correlations. And one thing I want to point out here is the p-values if you don't, well, I'll just show you. If I take them off and put the original p-value on, I get zeros because it's not formatted correctly. So I use a little DAX and put them in scientific notation using this format p-value, and this right here makes it scientific notation. So that'll look correctly on your visual. And the last one is just to show the contrast between the positive and negative correlation ones. So here's fruity. See, it's going totally opposite way of chocolate, crisp rice wafer, peanutty, almondy, nougat, and caramel, which all have positive correlations with winning percentage. So that's what I did. Hopefully you can use some of this in your entry for the Maven Halloween Challenge. I hope you liked the video. If you did, please like and subscribe, and I'll see you next time. Thanks, everybody.